Imagine, like, throwing a perfectly encrypted hard drive straight into a roaring fire.
Okay. Yeah, painful thought, but I'm with you.
Right. So if you are a student of classical physics, you are basically taught that the universe keeps a strict accounting of absolutely everything.
The great cosmic ledger.
Exactly. So theoretically, if you had this impossible supercomputer that could track every microscopic wisp of smoke, every single photon of light, every fleck of ash from that fire,
You could run the math backward.
you could run it backward and completely rebuild the data on that drive. The ledger always balances.
Right. In classical physics, sure.
But take that exact same hard drive and throw it into a black hole, and, well, the universe just fundamentally breaks its own rules.
Oh, it shatters them. I mean, because eventually that black hole evaporates, right? Through Hawking radiation.
Yeah, and the current math suggests that the radiation is just completely random.
Totally random. The information about the hard drive, its mass, its atomic structure, the actual data on it, it doesn't just burn up.
It seems like it gets wiped from reality altogether.
Yeah, which is terrifying if you rely on cause and effect.
Which brings us to the topic of this deep dive. The ultimate theoretical roadblock. The classic black hole information paradox.
The monster under the bed for quantum mechanics.
Exactly. But for this deep dive, we are taking a completely different approach. We are not going to try to find out where the missing information went.
Because asking where it went might actually be the wrong question entirely.
Right. So we are delving into a groundbreaking new treatise by Sriman Barua. It's brand new, dated May 27th, 2026.
Yeah, it's called Informational Persistence and the Admissibility of Discourse in the Absolute Medium. It's a heavy title.
A very heavy title. But Barua proposes this radical reframing. He argues that the paradox only exists because we have been, fundamentally misunderstanding the basic definition of what information actually is.
I mean, he basically says we've been looking at it all wrong for decades.
I love this concept so much. I mean, what if the universe isn't some giant cosmic hard drive trying to store every detail?
Right. What if it's something infinitely more dynamic?
So, to wrap our heads around this,
Yeah.
we need to go back to the dawn of the digital age. We have to look at the ontological error we've been making.
Yeah, we have to compare classical information theory against Barua's new absolute medium framework.
Let's trace it back to the Shannon-Weaver model.
Yeah.
That's basically the bedrock of classical information theory, right?
It is, yeah. It was originally developed to figure out how to, send messages over telephone lines without losing fidelity.
Uh-huh.
And because of that, it treats information as a quantifiable static commodity.
Like actual physical objects,
Yeah.
just bits and bytes sitting in a box.
Exactly. You can picture it as a sealed envelope. Classical physics treats information like this independent payload that just exists entirely on its own.
Whether anyone is reading it or not.
Right. Regardless of whether anything is interacting with it. And that assumption has just bled right into cosmology.
It's the entire root of the black hole paradox.
It really is. We assume that momentary state descriptors, like, say, the exact position and momentum of a specific electron at 2:00 p.m. on a Tuesday.
Yeah.
We assume those are rigid facts that the universe is just obligated to store indefinitely in some giant cosmic filing cabinet.
So, just to put this in everyday terms for you listening, classical physics treats information like a literal USB drive.
I like that analogy.
Right. You drop that drive into a black hole, and then you just stand outside the event horizon, demanding to know where the physical object went.
But Barua is just tearing that assumption down. He's saying information is not a USB drive.
It's more like a high five.
It's an interaction, an event.
Exactly, because you can't put a high five in a vault to save for later. It only exists in the active moment of transaction between two hands.
That analogy hits the nail on the head. Information is not a static object. Barua calls it an admissible state change.
An admissible state change, meaning it's a process.
Right. It's the process of state synchronization. In his model, the universe itself is not an empty vacuum just holding objects. Okay. He models it as an elastic, highly reactive substrate. He calls it the dissociative pressure field, or the DP field.
Okay, hold on. Dissociative pressure field sounds incredibly dense.
It is a mouthful, yeah.
Let's advocate for the student who is just trying to visualize this right now. Are we talking about a literal, physical grid in space.
Not exactly a rigid grid.
Or is this more like a fluid that bends and reacts when things move through it?
Yeah, think of it closer to a complex fluid, or like a topological web that just permeates absolutely everything.
Okay, a web.
Every particle, every force is really just a localized tension or movement within this dp field.
So for a high five to happen or any state change, the substrate itself has to flex and carry that interaction.
Exactly. And that leads to a massive realization. If the substrate can't carry it, the information simply doesn't exist.
Whoa, so it just doesn't register at all.
Right. He formalizes this in axiom 6 of his model. It's called finite structural coherence.
Okay, finite structural coherent.
Basically, Baru points out that information literally cannot exist below what he terms the L0 scale of the substrate.
Let me translate that. It's like if you drop a pebble in a lake, it makes ripples.
Sure.
But if you drop a single atom into a lake, the water molecules don't even register it.
Right. It's just too small.
It's below the scale of the medium's ability to react. And if the wave isn't big enough to actually move the water, it's not a wave.
That is a perfect way to look at it, and that completely undermines the idea of infinite microscopic data storage.
Because there's a floor to what the universe can physically track.
Yes. If you remove the systemic capacity of the dp field to resolve a state change, to literally physically support the interaction, the information density falls below the threshold of existence.
It just dissolves back into the background continuum.
Exactly.
So is classical physics is wrong, and our assumption about saving a momentary state is just flawed from the very start.
Which Barua argues it is.
Right. Then what actually makes up an informational interaction? If it's not a USB drive, but it's a high five, what are the physics required to make that interaction happen?
Without it just falling apart into background noise, you mean?
Yeah, exactly. How does it hold together?
Well, any valid unit of information has this irreducible anatomy. Barua formalizes this as the information triad.
The triad.
Mathematically, it's represented as the set U, and it consists of 3 parts, B, S, and D.
B, S, and D.
And these aren't just like bullet points on a chalkboard. They are mechanical necessities for a zero-defect transfer of a reality state.
Okay, let's see how they physically interlock. Walk us through the mechanism.
Sure. So you start with the objective state, which is the S.
S.
This is the raw, phenomenologically neutral payload. It is the factual measurement, totally stripped of any subjective bias or evaluative weight.
Think of it as just the raw numbers of a measurement.
Exactly, just the raw data.
But raw numbers don't mean anything in a vacuum. I mean, if I just yell the number 100 at you, that S is useless unless I give you the B, right?
Exactly the issue.
I need the boundary parameter.
Yes. Without the boundary parameter, the data lacks a domain. The boundary defines the scope, the coordinate system, the constraints of the inquiry.
Because 100 could mean anything.
Right. Are we talking 100 degrees Celsius, 100 miles per hour, 100 apples? Without the B, you get catastrophic ambiguity and universalization errors.
So we have the raw data, S, anchored by the context, B.
Yes.
But that still doesn't explain why the 100 degrees exists in the first place.
Which is why the whole system instantly collapses without D.
The causal driver.
The causal driver. This is the physical, mechanical, or logical linkage that forced the objective state to happen.
It's the how and the why.
Exactly. If you measure a temperature spike, the driver might be a chemical reaction. If you lack the causal driver, your data has zero explanatory power.
You're basically just staring at an unverifiable correlation.
Right. It's mathematically useless.
It's like a three-legged stool. If you drop the boundary, the state, or the driver, the interaction is logically unstable.
And the physical universe just can't sustain it.
But here is where my brain threw a huge flag when I was reading the paper.
Oh, I know what you're going to say.
Yeah. Barua takes this triad and plugs it into his meaning formula. He actually writes that meaning equals the information triad multiplied by the receiver's utility vector.
And the introduction of the receiver is a massive paradigm shift because it means meaning is not an inherent glowing aura surrounding the data.
Meaning is relational.
It is purely relational.
But wait, applying that to cosmology feels bizarre. I mean, if meaning requires a receiver's utility vector, how on earth does this apply to a black hole?
It sounds like a contradiction, right?
It really does. A collapsing star isn't a conscious listener decoding a message. Are we implying the physical universe itself is conscious and like listening?
That is a great pushback. It's totally crucial here to strip away the anthropomorphic baggage of a word like receiver.
Okay, so what is the receiver then?
In the absolute medium framework, the receiver is not a scientist with a clipboard. The receiver is simply the surrounding physical substrate.
The DP field itself.
Yes, the field is the receiver.
So the environment itself has to sort of accept the data for it to become real.
Exactly. For meaning or information to persist in reality, the physical system acting as the receiver must be able to process that state change.
Okay.
And it has to achieve what Barua calls a dynamically stable symmetry basin. This is heavily detailed in Axiom 8.
Axiom 8.
And it heavily relies on the persistence inequality.
Okay, let's build a mechanical analogy for the persistence inequality, because I think this is where the paper gets incredibly dense for a lot of readers.
It's heavy, yeah. Think about the thermodynamics of any event. Any interaction generates some level of incompatibility.
You mean like dissipation, thermodynamic noise, heat?
Yes, all of that. So for an informational transaction to actually leave a mark on reality, the system's ability to generate resolution has to be stronger.
Resolution meaning structure, clarity, or verification.
Exactly. The resolution must outrun the generation of that noise.
Oh, I love this. It's like trying to build a sandcastle while the tide is coming in.
That is a perfect visualization.
Right, so the sandcastle is your information triad. The crashing waves are the thermodynamic noise.
And if you can't pack the sand...
If you can't pack the sand and build the structure faster than the waves wash it away, your information never persists. The environment, the receiver, just couldn't stabilize it.
Spot on. If the DP field cannot physically process and resolve the state change against the incoming noise, the meaning is functionally zero.
Wow.
The information doesn't go to some secret hiding place. It simply fails to exist as a persistent reality.
Which completely flips how we view physical evolution.
Right.
We're no longer tracking these indestructible marbles bouncing around in a box.
Right, it's not a vault.
We are watching a continuous negotiation between structure and noise. And that brings us to the real meat of the black hole problem.
The distinction between momentary state and generative structure?
Yes. This is where we start actually solving the paradox. We've redefined information as a structural interaction.
A topological flexing of the medium.
Right, rather than a static object. So now we apply that to a massive evolving system, like a star burning out and collapsing.
We have to define these two terms carefully, though.
Yeah, for the listener, these are the absolute key to the whole paper. What is a momentary state versus a generative structure?
Okay, a momentary state is a realized configuration of a system at a microscopic, fleeting stage in the arrow of time.
Okay, have me an example.
It's the exact position, phase, or momentum of one specific photon inside that star at one specific nanosecond.
And classical physics demands we save that exact nanosecond.
Exactly. But Barua says once this moment passes, it is absolutely not fundamentally conserved.
Because a realized state belongs to what has already happened. It was an event.
It was the high five.
The high five. Once the hands part, the high five cannot remain stored somewhere as an invisible ghost. The universe does not hoard snapshots.
It really doesn't.
So if the snapshots are thrown away, what actually does persist?
The generative structure.
Okay.
This is the lawful organization of the substrate. It includes the boundary architecture, the causal lineage, the topological rules of the DP field itself.
And the reconstructive potential of the medium.
Yes, exactly.
Let me try to ground this with another analogy for the students listening. It's like tossing a wooden chair into a bonfire.
Okay, I'm tracking.
The momentary state, that specific physical four-legged chair you were just sitting on, with its exact scratches and splinters, that is gone forever once it burns.
Right, the momentary state is ashes.
But the generative structure, the underlying laws of carbon combustion, the physical rules of atomic bonding, the very structural concept of chair building, that survives perfectly intact.
Oh, that's brilliant.
Rebuilding a new chair tomorrow doesn't mean the original chair was secretly preserved inside the ashes.
It just means the universe retained the capacity to build chairs, and this actually exposes a huge trap that physicists fell into regarding mathematical reversibility.
Oh, right, because the math of quantum mechanics works perfectly backward and forward in time.
Exactly the trap. Since the equations are formally reversible, we naturally just assumed the original event was conserved.
We assumed the chair was literally hiding in the ashes.
Yes, just waiting to be unburned. But Barua draws a really hard line here. He separates formal reversibility from ontological conservation.
Right, because mathematical reversibility just gives us conditional reconstructibility.
It's a blueprint. It is not a time machine.
That is a great way to put it.
You can conditionally recreate a prior state form, sure, but only if you have the correct boundary conditions and a massive fresh supply of energy.
Because reconstruction is an active physical act.
Yes, of lawful reformation. Reinstantiation has a massive thermodynamic cost. It demands fresh ordering conditions.
It is absolutely not the passive retrieval of a stored object from a cosmic hard drive.
Not at all. Which means all those physicists losing sleep over where the exact momentary states of the black hole's matter went?
They were looking for a ghost.
They were.
So taking everything we just discussed, the high five, the sandcastle, the burning chair, what actually happens to the generative structure when matter crosses the event horizon of black hole?
This is the climax of Barua's paper.
Where does it all go?
Well, we finally arrive at the singularity. The standard paradox insists that every minute detail of the collapsing star must be perfectly encoded in the singularity.
And eventually leak out in the Hawking radiation.
Right, but Barua says this assumes an archive ontology.
It assumes the universe is a hoarder.
Exactly. But under the AM axioms, specifically the hard irreversible boundary axiom, the universe physically forbids pathological continuation into singular states.
Okay, hold on. That phrase belongs in a textbook. Let's translate that for you listening.
Hmm.
Forbids pathological continuation into singular states.
It's very dense.
Basically, he means the universe flat out refuses to allow infinite density. You can't just crunch infinite data points into a point of zero volume.
The DP field will allow it.
The medium snaps back.
Yes. Instead of crushing into an impossible singularity, the DP field reorganizes under extreme strain. The information isn't vanished, but it also isn't stored.
It redistributes into two new topological sectors, right?
Yes, two sectors.
Let's break those down. What is the first one?
He labels it IOHOR, which stands for Horizon-Encoded Content. As the matter falls in, the generative structure, the rules of the matter, leaves a topological imprint on the event horizon itself.
Okay.
It physically alters the boundary condition of the black hole.
So it's like a scar on the surface of the DP field. It's not the original matter, but it's the structural memory of the mass and spin that warped the field.
That's a great visual.
What is the second sector then?
The second is the topologically protected internal sectors. Inside the horizon, the substrate reorganizes into stabilized internal geometries.
So it doesn't compress into a tiny dot.
No, it weaves into a new structural format that is protected from the thermodynamic noise of the outside universe.
Honestly, this completely rewrites the final exam on black holes.
It changes everything.
Baru is saying the information isn't lost, but it is absolutely not stored in the classical sense. It is legally translated into a new topological format.
Yes, a translation, not an archive.
We just need to stop looking for the missing bits of the star's momentary state and start looking at the horizon's capacity for reconstructive potential.
It resolves the crisis by fundamentally changing the nature of the universe. Black hole collapse isn't a paradox of a broken hard drive anymore.
Right.
It is just a transition in admissible medium structure under extreme gravitational strain.
Baruch calls it a field of structured becoming. I just find that phrasing so elegant.
It really is beautiful.
It means the universe is constantly moving forward, negotiating with noise and maintaining the rules of existence without being burdened by hoarding every single microscopic snapshot of the past.
It shifts physics entirely from an archive ontology to a generative ontology.
Wow.
You don't need to save the data points if the universe never forgets how to generate the laws of physics.
The capacity to build the structure is conserved, even if the specific structure itself is allowed to fade.
Exactly. And it implies that our very understanding of the cosmos, our equations, our observations, are governed by the exact same admissibility logic as the physical matter falling into that black hole.
Every interaction is just the universe seeking a stable symmetry basin.
Yes.
That is beautifully put. But I want to leave you, the listener, with one final, deeply provocative thought.
Oh, this is the part from section 7.4.
Yes, derived directly from the cosmological implications in section 7.4 of Barua's text. It actually has to do with the nature of observation itself.
The ultimate test of the receiver's utility vector.
Exactly. Barua mentions that observation isn't passive. Observation itself is a physically mediated synchronization event.
It is a transaction.
Right, remember, meaning requires that information triad to interact with the environment, the receiver. So, what happens to the information of a massive astrophysical event that occurs entirely unobserved?
Oh, man. It's like if a tree falls in a forest and no one is around to hear it, but on a cosmological scale.
Exactly. Think about a massive star collapsing into a black hole. in a completely isolated, unobservable pocket of the early universe.
Just billions of light years from anything that could interact with its light or gravity.
Right. There is no surrounding substrate capable of stabilizing a symmetry basin. Does that unobserved collapse even possess meaning?
That's the question.
Or does it exist purely as raw, undecoded generative structure, like an event that never truly materialized because the universe wasn't ready to receive it?
It's a profound, almost dizzying question. I mean, if the high five never meets the other hand, did it happen?
Exactly.
In the absolute medium framework, unobserved physical reality might just be waiting in a state of unresolved reconstructive potential.
It's enough to make your brain hurt in the best possible way.
Absolutely.
So the next time you look up at the night sky, remember, you aren't living inside a rigid cosmic hard drive. You are actively participating in a universe that is a dynamic field of structured becoming.
Every observation is a transaction.
Thank you for joining us on this deep dive. Keep questioning your assumptions, and we will catch you next time.